Hello class, so this is the review for midterm 1 part 2 which covers chapter 3 and 4. So you guys need to know a normal distribution from chapter 3 and their properties. Um we also have an example of heights of males and also females, and we can see that they have reported slightly a higher height, right? That's why their distribution is still normal, but it's slightly shifted to the right? So it's slightly shifted. And so same case for women, they have also like maybe exaggerated their height. Like people usually when they create a profile, maybe they like exaggerating. So you guys need to know that, right? So if it's centered at 0, so you guys should be also familiar with this type of graphs, right? If the standard deviation is 1, so this is called the standard normal, and this is if the it's centered at 19 and standard deviation is 4, right? Again, an example like the SAT scores. The SAT scores with mean like 1500 and standard deviation 300. So Pam had earned like 1800 on her SAT, and Jim scored 24 on his ACT score, right? So SAT and ACT are different, right? Okay. So how do we compare them? So to compare them, we need to standardize it into Z form, right? So if you standardize in Z form, then you can compare how Pam did relative to Jim, right? So you guys are familiar, I have discussed it in class. So work through the example, like how they have standardized. So it's, and this is the formula you guys should be using, right? Like x minus mu over the standard deviation. That's how you actually find z, right? You guys also need to know what's a percentile is, right? So percentile is the percentage of observations that falls below a given data point, right? And if we try to find the percentile, so if a z value of, let's say I want to find the percentile of a z value of 1, it would be 84 percentile, right? So if I draw a normal distribution, okay, so let's say I draw a normal distribution here, and if z value is 1, then if 1 is here, minus 1 should be there. This entire area would be 0.8413, right? So you can easily find, like if I tell you to find the percentile, you should be easily able to find that, right? So again, an example, so suppose the mean is 36 and they do a quality control, so they want to see how much of the percent is within 36, right? So in this hence example, so you know x is 35.8 and 36 is the mean, and first we need to calculate the z value. So if z value is minus 1.82, then we can go to the minus 1.82, and from the table we find that to be 3.44%. Now that minus 1.82, it's here, right? Minus 1.82. So anything to the right, they are actually calculating this area, which is 3.47, right? So if it was plus 1.82, I have always mentioned in class that if it is plus 1.82, they would calculate the area after this, right? Okay, so always the reading is to the left. So if it's a normal distribution, like minus 1.82, always the area is to the left. If it is plus 1.82 over here, it's the reading should be always to the left hand side, right? So minus 1.82, if I draw it as a normal distribution, minus 1.82 is here, and the area they would be giving me is always to the left hand side. So that area at minus 1.82 would be minus 1.82 is this area, right? You can do this example like what percent of bottle, so you can practice this example. So it ranges from 1.82 to minus 1.82 to 1.82, and that area is basically, see, so that area should be between, so if it is 1.82 they calculate this area, if it is minus 1.82 they calculate this area, right? So let me just, so, and if you subtract, so this is for plus 1.82, this is for minus 1.82. If you subtract this area minus this area, you will get the total area to be 0.932, right? So I have done this in class like couple of times, so it should be really easy for you guys. In fact, let me just create my own, because this is important. Like if I tell you find the area of from 1.82 to minus 1.82, so how to do it? So let me draw it in paint. All right, so this is very important. Okay, so I give you a normal distribution. I tell you this is minus 1.82 and this is minus, so this is plus 1.82 and this is minus 1.82. Find the area between them. So when you calculate for plus 1.82, that area is basically the shaded region of this whole part, right? And so that let's say it's 0.96 for plus 1.82, right? So for plus 1.82 of z value, I got the area is 0.96. Now for minus 1.82, if I tell you to find the area for minus 1.82, they will give you always on the left hand side, and that, let's say that area is 0.03. So what is your total area? So total area from 1.82 to minus 1.82 is the blue area minus the red area, right? So blue area is 0.96, red area is only 0.0, so the net area is 0.93 in that case, because I have to subtract the blue area minus the red area, right? I did it in class, so it should be clear by now, right, if you have attended the class. So that's one thing you have to find. I will also ask how to find a cutoff point, so you guys need to find the cutoff point. Like I will give the z values, and then maybe I will tell you guys to find the x value, right? So z value will be given, then x. So this you guys should know. You guys should also know that with 68%, there's one standard deviation. 95% covers 2 standard deviation, and 99.7% covers 3 standard deviation. So that's also you guys need to know. You guys also need to know the formulas, right? You can always create a formula sheet, right? So it's straightforward, in fact, right? You guys need to know the normal probability plot, right? So that's straightforward. You can practice this. In fact, if it is right skewed, then points bend up and to the left of the line. If left skewed, then points bend down and to the right of the line. So you guys can check the properties. I also discussed in class the Bernoulli distribution, which is a success or fail. For a Bernoulli distribution, right? This is the formula for the mean, right? If you recall, you need to know the mean formula, and you also need to know the standard deviation, right? So these are the formulas you can write for a Bernoulli, all right? And binomial is a Bernoulli like a Bernoulli distribution, but n times. So for a binomial distribution, this is the formula we actually should follow. You can practice this example, right? In fact, I might give you guys this question so you can practice. Maybe I'll change a little bit here and there. All right, and this is the formula for the mean of a binomial. This is the formula for a standard deviation, right? Unusual observations, so you can read about that, right? In fact, this is a good example that may show up in the exam, right? So make sure you practice those things, right? I talked about margin of error, like how to you guys have to find like a mean, what's a population mean, what's a sample mean, again some repetitions, what are the CLT conditions, central limit theorem, right? So the conditions are independent, sample should be skewed. What's the confidence interval, maybe I might ask, right? And if you look, there are some formulas, you might need to use those formulas, right? So it is a worked example, so maybe a similar type of question might appear in the midterm. Okay, so again, these are the CNT conditions. If we have a wider interval, what's the problem? Then it is not very informative, right? So changing the confidence interval, so you guys have to look at a different level of confidence interval. In fact, I gave the critical values for Z, right? If you recall, Z 1.96 is 95%, Z 1.645 is 90%, Z 1.28 is like 80%, right? Some hypothesis test, you guys should be familiar with those hypothesis test, right? Using confidence interval, so this is going to be important, right? And what's a test statistic? So you guys need to know that what's a test statistics, what's p-value, and when to reject it, right? If it is low, important. So p-value, by looking at p-value of 0.03, we can in fact find the z value, right? So 0.03, let me just use this, the z value is minus 3.4, right? So, or 3.4 in fact, right? So you guys would be able to follow that. And this is the one that actually the most important one, the type 1 error, type 2 error, which we have discussed in class couple of times. You can also like this might come up in the exam, right? So that's very important. And as well as like there are some worked examples, so you can actually look at this practice problem, which can help, right? Or like for nearly point estimates, this is kind of important. All right, so what happens when n increases? It behaves like normal, right? So you guys can actually look at this. It's a very important, in fact. Like I can ask these questions: when n increases, what happens? The distribution behaves like a normal distribution, right? So that's about it for review for chapter 3 and 4. Um, and I would also like to talk about the homework problems. So mostly like the homework problems, you guys did pretty well in the few questions you got stuck was, I believe it was, most of you guys had some problem with like 1.6D, or also there is 2.35. Okay, so make sure you practice question 2.35 from homework 1. I have seen, like, I have graded your copies and you guys faced a little bit of problem regarding that, and the other ones you can work through the problems, right, for homework 1. Okay, and for the homework 2, you guys did pretty okay, but some minor mistakes here and there, like practice 3.17, 3.17 or 3.18, similar type of questions, or like a 3.21. Okay, these type of questions might appear, and some of you guys made mistakes in 3.25. Okay, so 3.25, I recommend you guys to look at it. Okay, right, and for the hypothesis testing, you guys have to practice like 4.17 and 4.18. Those are the ones, like some of you guys just wrote like one-tailed, but actually it's a two-tailed test. All right, so like wrote greater than 1100 for 418, or even in, and the central limit theorem is this 4.33. So these are the type of questions that are going to be in the exam. And I also want to discuss about the normal table. So if it's z value of, let's say, if I tell you to find, a z value, you should be able to find it in like easily, right? So if z value, if I tell you to find 1.8, it's 0.964. So 1.8 means the positive 1.8 and anything area to the left. Okay, any area to the left. And negative 1.8, similarly, if negative 1.8 I want you guys to find, negative 1.8 is 0.0294, right? No, in fact, negative 1.8 is 0.0359, right? So anything to the negative side. So always, the table readings would only give you the left hand side readings, so you have to find the area accordingly. Okay, that's the most important. And for t distribution, we have the degrees of freedom, right? So, and it can be one tail and two tail, right? In fact, I am going to upload this in the Blackboard, the probability table, and I'll give printed copies in the exam so that you can practice. Okay, thank you.